Before there were stars, there was light, not the kind that burns in the heart of suns or glows softly on a distant horizon, but something older, something woven into the very birth of existence itself. It drifts all around us even now, faint and patient, a whisper that began before time had meaning, long before Earth took shape, before galaxies coiled into spirals, before atoms learned to hold hands and become matter. There was this light, an ocean of soft radiance expanding endlessly into the newborn dark. It has traveled across the entire age of the cosmos, untouched and unstoppable. Every second it brushes against us, passing through empty rooms and silent skies, unseen yet ever present. We don't feel it on our skin or glimpse it with our eyes, but it's there, a soft echo from the moment creation first exhaled. It's the oldest thing we can still perceive, older than the stars that guide sailors, older than the dust beneath our feet, older even than time as we understand it. This light carries the memory of a universe that was once only heat and chaos, a storm of beginnings too bright for life to endure. And yet somehow, fragments of that brilliance survived, stretched thin, cooled, dimmed, but never extinguished. What began as a blaze fierce enough to unmake everything became a murmur, gentle enough to reveal it all. It isn't the light of any single star or galaxy. It belongs to everything, and to nothing in particular, a universal afterglow, scattered like ash from the first fire. Scientists would one day give it a name, but for now, imagine it as the universe's first photograph, blurred, ancient, and infinitely delicate. A portrait, not of what the cosmos became, but of what it once was. This light still travels, endlessly. It was never meant for eyes, yet it finds them. And when we finally learn to see it, we'll uncover not only how everything began, but how everything might one day fade. Before light, the universe glowed, not with illumination, but with chaos. Imagine everything that would one day exist, every galaxy, every atom, every heartbeat, compressed into a single trembling instant of unimaginable density. It wasn't darkness in the way we know it, because darkness implies the absence of light. This was something deeper, a brightness so complete it blinded itself, a storm of energy where nothing yet could shine. At the very beginning, the universe was not vast. It was infinitesimal, smaller than an atom, denser than any star, hotter than the core of 1,000 suns multiplied beyond thought. In that first fraction of a second, all the laws of physics we depend on today were tangled together in a single primal force. Gravity, electromagnetism, the strong and weak nuclear bonds, everything was fused into one. The universe didn't expand into space. It became space, unfolding from a point that wasn't anywhere into everywhere at once. This was the era of inflation, the most violent expansion in all of history. In less than 1/trillionth of a second, the universe swelled from subatomic to cosmic, stretching faster than light, not through space, but as space itself. It was as if the fabric of existence inhaled sharply, and in that breath, time began. The edges of the possible were rewritten. Energy became the seed of everything, but it wasn't stable. It boiled and churned in a fever of creation, a sea of quantum fluctuations birthing and destroying themselves faster than imagination allows. In those moments, there were no particles, no atoms, no stars, only an ocean of pure energy so intense that even the concept of form was meaningless. Reality was molten. Space and time wavered like heat rising from desert sand. The newborn cosmos pulsed in waves of possibility, and within it, the foundations of everything to come were being written, not as matter, but as potential. 1,000,000,000,000 degrees filled every cubic inch of existence. It was the temperature of creation, and it was unbearable. Matter, in any familiar sense, could not exist. The very notion of a thing was impossible when everything was too hot for stability. Quarks, the building blocks of protons and neutrons, roamed free, unable to bind. Gluons, their invisible tethers, flickered in and out of being, trying to hold together a universe too wild to be held. For a moment, it seemed that nothing permanent could ever emerge. The universe was a quark-gluon plasma, a churning cosmic soup where energy and matter blurred into one continuous storm. Photons, the particles of light, did exist, but they couldn't escape. The universe was so dense that light scattered endlessly, trapped within the opaque fog of its own birth. Imagine a storm so thick with fire that the flames cannot glow, only seethe. That was the first darkness, the brightest darkness that ever was. If you could somehow stand within it, you wouldn't see light. You wouldn't see anything at all. There was no view, no horizon, no separation between one place and another. Every point in space was the same as every other. The universe hadn't yet learned how to be different. Time itself was struggling to emerge from chaos, its arrow still wavering between forward and back. Cause and effect blurred into one timeless vibration, like the trembling of a note before sound is born. And yet, beneath this turbulence, patterns began to form. The quantum foam, microscopic fluctuations in energy density, started leaving tiny scars on space-time itself. These were the first fingerprints of structure, invisible wrinkles that would one day guide galaxies into being. Randomness was sowing order, like ripples frozen in glass as it cools. The universe was still too hot for light to travel freely, but in its blindness, destiny was taking shape. As expansion continued, the searing intensity began to ease. Trillions of degrees dropped to billions, then millions. Space itself was stretching faster than light could traverse it, and with every breath of expansion, the firestorm thinned. The first second of existence ticked by, a moment both infinite and fleeting. Within it, the raw forces of the cosmos began to decouple. Gravity pulled apart from the grand unity first, claiming dominion over mass and motion. Then the strong nuclear force solidified, locking quarks together into the first protons and neutrons. The universe, for the first time, had ingredients. Rough, primitive, but real. Still, the fog remained. Photons, the messengers of light, continued to collide with particles so often they couldn't move more than an instant before being scattered. Every atom that tried to form was torn apart by the heat. The universe was an orchestra tuning itself in violent dissonance, its melody still trapped in noise. This was not chaos without purpose. Each collision, each random burst of energy, each flicker of a virtual particle appearing and vanishing contributed to balance, to cooling, to structure. The universe was not exploding into emptiness. It was condensing into meaning. It was not a blast, but a bloom. If we could slow this early epoch to human pace, we would watch energy unravel into matter, matter into radiation, radiation back into matter again, a cosmic dance that never stopped moving, never paused to rest. Protons and neutrons began forming fragile unions, brief and unstable. Some fused into light elements, hydrogen, helium, and traces of lithium. The recipe for all stars to come was being written in this brief, blinding crucible. Even so, light was still imprisoned. For hundreds of thousands of years, the universe remained opaque, a fog so dense that photons could travel only the tiniest distances before bouncing off free electrons. It was a cosmos without transparency, a cosmic womb where sight itself was impossible. To call it darkness would be misleading. It was radiant beyond comprehension, but that radiance was trapped, folded inward, hidden behind its own brilliance. In that radiant blindness, the stage for light was being set. As the universe expanded, the temperature continued to fall. By the time it cooled to around 3,000 degrees Kelvin, roughly the heat of a candle flame, the fog began to lift. Free electrons finally found partners in protons, forming stable atoms of hydrogen. For the first time, light could move freely through space without being scattered. The universe took its first clear breath. But before we reach that dawn, linger a moment longer in the darkness that came before. Think of it not as emptiness, but as gestation. Everything we know, the stars, the galaxies, the laws of physics themselves, was being forged inside that radiant prison. The chaos before light wasn't meaningless. It was the foundation upon which meaning could exist at all. The paradox of creation is that to see, there must first be blindness. The brightest light can only emerge from a darkness dense enough to contain it. The universe, in its first moments, wasn't hiding the light. It was becoming it. Every particle of energy that ricocheted through that storm, every quantum fluctuation and fleeting spark, carried within it the potential for illumination. Imagine a sea of molten glass, cooling slowly. At first, it is opaque, turbulent, impossible to see through. But as it settles, it begins to clear. Shapes form, reflections appear, and transparency is born. The universe followed a similar path, its firestorm settling into clarity, its brilliance learning how to shine. Time, too, began to stretch, to take shape. What had been measured in microseconds now became seconds, then minutes, then years. The universe was learning patience. The violent immediacy of the Big Bang was softening into rhythm, into continuity. Space no longer exploded, it expanded. Light no longer fought for freedom. It waited. Every flicker of that waiting was a story forming. The first atomic bonds, the first stability, the first glimpse of identity. The cosmos was learning to remember, and somewhere within that memory, hidden in the frequencies of its cooling glow, the oldest light was preparing to emerge. It's easy to think of the early universe as alien, something separate from us, but that same chaos is written inside every atom of our being. The quarks that once swam freely through the primeval plasma now rest inside our bones. The photons that were trapped in that ancient fog still hum through the air around us. We are made of the cooling of that fire, the slowing of that expansion, the calming of that storm. The moment before light was not the end of darkness. It was its transformation. In the heart of that blinding opacity, the universe was already luminous. It just hadn't yet learned how to see itself. And when it finally did, when light broke free for the first time, the afterglow would become the oldest story ever told. That story still surrounds us today, faint but eternal, a whisper from the age before sight, before stars, before even time could keep track of itself. In that instant, the universe took its first breath, and light escaped. For 380,000 years, creation had been blind, its brilliance trapped within itself. Every photon was born and buried in the same moment, colliding endlessly with free electrons in a fog so dense that even the concept of sight was meaningless. But slowly, relentlessly, expansion had cooled the firestorm. The once blinding inferno of plasma began to ease, like molten glass setting into clarity. The chaos of the beginning was softening into form, and in that softening, the universe prepared for its first great revelation: transparency. This moment is known as recombination, not because the universe was coming together, but because it was learning how to bind. Until now, matter had been a seething plasma of free electrons and protons, an unrelenting storm of charges that scattered light like mist scatters dawn. But as temperatures fell to around 3,000 degrees Kelvin, something miraculous happened. The electrons slowed enough to be captured by protons, forming the first stable atoms of hydrogen. In that instant, the fog lifted. For the first time in all of history, light could move freely through space without being trapped or torn apart. It was the universe's first clear breath, the birth of vision itself. Those newly freed photons fanned outward in all directions, no longer colliding, no longer bound by the suffocating plasma that had held them prisoner. They were the first travelers, the first witnesses, and they never stopped. Every one of those ancient particles of light has been journeying through space ever since, stretched thinner and colder with the universe's expansion, yet still carrying the imprint of that first luminous freedom. When we detect them today, we are not seeing where they are, but where they were, echoes from a time when the cosmos opened its eyes. That afterglow is what we now call the cosmic microwave background, though in truth, it's not a background at all. It's everywhere, in every direction, evenly spread across the heavens like the residue of a universal memory. It's not just around us, it's within us, woven into the silence between every atom. Look anywhere, into the deepest darkness of space, and you are staring directly into the first light the universe ever released. At that time, there were no stars yet, no galaxies, no shapes or shadows. The universe was still simple, filled mostly with hydrogen and a hint of helium, but for the first time, it could see itself. Imagine a fog lifting to reveal not a landscape, but infinity itself. The first photons raced across the emptiness, untouched and unstoppable, leaving behind a faint glow that has never faded completely. What's astonishing is that this happened not billions, but mere hundreds of thousands of years after the Big Bang. Less than a heartbeat compared to the universe's age today. And yet, the light from that moment has traveled for 13.8 billion years and still hasn't reached the end. It can't, because the universe has no edge. Every second, space expands further, stretching the very wavelengths of those ancient photons like elastic threads of memory drawn across eternity. This stretching is what has turned that primeval fire into a whisper. What was once searing white-hot light is now cooled to a faint microwave signal, a relic so cold it sits just above absolute zero. The color of creation has faded, but not disappeared. Those photons still move, still carry the fingerprints of that first dawn, encoded in temperature variations no stronger than 1 part in 100,000. To us, that variance may seem trivial, but hidden in those tiny ripples is the blueprint of everything that would come. Galaxies, stars, planets, life. Imagine those photons as time capsules, each carrying a frozen imprint of a moment when the universe was barely old enough to see itself. When scientists map the sky at microwave frequencies, they are not looking into distance, but into history. A portrait of the infant cosmos. The faint speckling we see isn't noise. It's the memory of density itself. Where the radiation was slightly warmer, matter was denser, and gravity would later sculpt those pockets into galaxies. Where it was cooler, voids would open, leaving space for everything else to grow. The light, in other words, remembers. It is easy to mistake this for a poetic metaphor, but it's literal. The cosmic microwave background is a record, an image etched in the radiation of the early universe. Every photon we detect from it carries information about that ancient moment. The density of the plasma, the rate of expansion, the seeds of cosmic structure. The universe's first light was also its first memory. A cosmic photograph imprinted before there were even eyes to see it. And what does that photograph show? It reveals a cosmos astonishingly uniform, almost perfectly smooth, differing in temperature by less than 100,000th of a degree from one place to another. Yet those tiny imperfections were everything. They were the fingerprints of randomness, the breath of quantum fluctuations from the earliest moments stretched to cosmic scales. Without them, gravity would have had nothing to work with. No galaxies, no stars, no us. The universe was born almost perfectly even, but not quite. It is in that imperfection that beauty and structure found their home. If you could somehow see this light with your naked eyes, it would not appear bright. It would glow faintly in every direction, a soft, reddish shimmer just beyond the visible spectrum. You wouldn't be able to tell where it begins or ends because it has no boundary. Every direction would look the same, as though the entire universe were wrapped in an endless, gentle twilight. This is the paradox of the oldest light. It shines everywhere, but nowhere brighter than anywhere else. Every telescope that gazes into that radiation becomes, in a sense, a time machine. The detectors don't capture light as it is. They capture light as it was. To map the cosmic microwave background is to witness the very moment when darkness learned to shine. When the universe, after ages of blindness, took its first look around. Philosophically, it's difficult not to see something profound in this. Before that instant, light existed only as confinement, as struggle, radiation imprisoned by matter, unable to escape. But with recombination came liberation. The light that once burned itself into stillness found freedom in expansion. The photons released that day became the storytellers of the cosmos, messengers from a time when existence itself was young enough to remember its birth. Every time you turn on a television and see static, a small fraction of that noise about 1%, comes from those same ancient photons. They have passed through galaxies and voids, through clouds of gas and stretches of nothing, yet they still reach us. When you close your eyes and imagine the universe before stars, you are not imagining silence. You are imagining that glow. The light that began its journey then is still crossing your skin now. As expansion continued, this first light spread outward, growing cooler and redder. What began as visible radiation shifted into infrared, then microwave, and one day, far into the future, it will stretch beyond even that, fading into wavelengths too vast to measure. And yet, even as it fades, it will endure, because the universe remembers through its light. If you could hold a photon from that time in your hand, if such a thing were possible, you would be holding a moment older than stars, older than galaxies, older than the very dust that forms planets. That photon has never stopped traveling, never changed course, only slowed in its rhythm as space itself expanded beneath it. It is the closest thing we have to eternity in motion. What's remarkable is how calm the universe became once light was free. The great turbulence of the plasma age had ended. With the fog gone, space turned dark, transparent, silent. The first atoms drifted like seeds in a vast, cooling field. The universe was 380,000 years old, still an infant, but now capable of reflection, of letting light pass without interference. This was the first dawn, not in the sense of daybreak on a world, but in the sense of perception itself. The first time the cosmos could see. And yet, this clarity was not yet illumination. There were no stars to shine, no galaxies to scatter starlight through the void. The universe had become transparent, but it was also dark. The photons of the CMB provided a dim, omnipresent glow, but nothing new replaced them. The stage was ready, but the lights had yet to rise. For millions of years, the universe would drift through this cosmic dark age, filled with invisible potential. Still, that faint radiance persisted, undying. And it is through that radiance that we, billions of years later, can trace the first heartbeat of the cosmos. It is through that glow that we measure the universe's age, shape, and destiny. When we listen to that whisper of microwaves, we are hearing the voice of creation, stretched by time but not silenced by it. The CMB is not just a relic. It is a mirror. It reflects not only what the universe was, but what it would become. The same fluctuations that painted its surface are the ones that seeded galaxies, stars, and ultimately consciousness. In its grainy texture lies the story of everything that followed. Perhaps the most humbling truth of all is that we exist because the universe cooled enough to see itself. If recombination had never happened, if the fog had remained, light would never have escaped, matter would never have coalesced, and the cosmic story would have ended before it began. Instead, in one breathtaking moment, the darkness learned to shine, and that light, born 13.8 billion years ago, still surrounds us. Every photon that brushes your face, every frequency that hums through the silence between stars, is a continuation of that first exhale. The light does not end. It only changes form, stretching forever as the universe expands. It is both past and present, memory and motion. So when you look into the deepest part of the night sky, you are not gazing into emptiness. You are looking at the universe remembering itself. the afterglow of its first awareness, still burning softly after all this time. Every direction you turn, every shadow you chase, every quiet moment beneath the stars. There it is, the first light, the oldest story, the dawn that never ended. It began with a noise, faint, persistent, and utterly mysterious. Two engineers, Arno Penzias and Robert Wilson, were trying to perfect a radio antenna in 1964, high above the bustle of New Jersey, searching not for the secrets of the cosmos, but for clarity in communication. Yet, no matter what they did, no matter how carefully they cleaned the equipment, adjusted the receivers, or even removed the pigeons nesting inside the dish, the static would not go away. It came from every direction, unwavering, steady, and unlike anything they'd heard before. What they didn't yet know was that the noise was not local. It wasn't the Earth, the Sun, or even the galaxy. It was coming from everywhere at once, an invisible hum woven through all of space. Penzias and Wilson had stumbled upon the oldest light in existence, the very afterglow of creation itself. The universe, it turned out, still carried an echo of its birth, and it was whispering through their antenna. That static, the cosmic microwave background, became the most important signal humanity has ever detected. Hidden in its faint, featureless glow is the blueprint of everything that would ever be. For billions of years, this ancient light had traveled through space, unnoticed, unchanging, until a pair of puzzled engineers gave it a name. What they found was not just radiation, it was a map, a cosmic baby picture frozen in time, showing the universe when it was only 380,000 years old. Imagine that. A photograph 13.8 billion years in the making. A portrait of the cosmos before stars were born, before galaxies swirled, before darkness learned to twinkle. What seems like a uniform wash of light actually holds subtle variations. Tiny fluctuations in temperature, differences of mere millionths of a degree, but in those minuscule ripples lay destiny itself. Those faint ripples became every star, every planet, every one of us. Each fluctuation in that ancient glow marked a region of slightly different density. Some a touch thicker, some a touch thinner. Over eons, gravity would pull the denser spots inward, condensing matter into galaxies and clusters. The lighter regions would become vast cosmic voids, empty stretches of near-nothingness between the filaments of creation. What began as a barely perceptible unevenness in the fire of the early universe would sculpt everything that followed. When scientists first began to study the CMB in detail, they found not chaos, but astonishing precision. The radiation was almost perfectly uniform, 1 part in 100,000. Such smoothness suggested a cosmos that had expanded evenly, cooling predictably, governed by deep symmetry. Yet the slight imperfections were exactly what was needed. Too much irregularity, and the universe would have collapsed back on itself. Too little, and it would have remained a diffuse mist, never forming stars or life. The cosmos had balanced itself on the razor's edge of possibility. The discovery of the CMB changed cosmology forever. It confirmed what theorists had suspected but could not prove, that the universe began hot, dense, and rapidly expanding. It gave substance to the idea of the Big Bang, not as a metaphor, but as measurable reality. The temperature of the CMB today, a mere 2.725 Kelvin above absolute zero, tells us how much the universe has stretched since that first flash. Its faint ripples reveal how matter clumped together, how fast space expands, and even how much of it is made of mysterious dark energy and dark matter. In 1992, the COBE satellite gave humanity its first true glimpse of the texture of this ancient light. For the first time, we could see the universe as an infant, not smooth but slightly dimpled with cosmic fingerprints. Those dimples weren't imperfections. They were potential. They were the first hints of galaxies waiting to be born. Later, NASA's WMAP mission and the European Space Agency's Planck Observatory refined that image to breathtaking detail. The CMB was revealed not as a blur, but as an intricate tapestry, an exquisite pattern of temperature variations, each a clue to the forces that shaped existence. By studying the spectrum of those fluctuations, scientists could infer the age of the universe, its geometry, its composition, and even its fate. The CMB tells us that the universe is flat, not in the sense of shape, but in curvature. Space, at the largest scales, does not bend inward like a sphere or outward like a saddle. It stretches evenly in all directions, a testament to the inflationary expansion that occurred in its first heartbeat. It also tells us that ordinary matter, the kind that forms stars and people, makes up less than 5% of everything that exists. The rest is unseen. Dark matter binding galaxies together, and dark energy tearing them apart. All of this knowledge, all of this understanding, hidden inside a sky full of microwaves. To read the CMB is to read the autobiography of the universe written in light. Each pixel of its map represents a place and a time, an ancient vibration frozen into the sky. To the untrained eye, it looks like abstract art, blotches of red and blue, cold and hot, scattered without meaning. But to cosmologists, it's scripture. Those colors are temperature differences so small that they would make the difference between warmth and frost feel like an inferno. Yet, from that barely perceptible imbalance came the totality of creation. Think of the CMB as the ultimate photograph. Light captured not by a lens, but by time itself. Each photon that reaches our telescopes today began its journey at the dawn of transparency, when atoms first formed. It has traveled unbroken ever since, carrying within it the story of every collision, every pull of gravity, every echo of expansion it has ever encountered. When we map that light, we're not looking outward, we're looking backward. The night sky becomes not a ceiling, but a mirror reflecting the earliest moments of being. This is perhaps the most profound paradox of the CMB. Every direction we look, we are staring into the same ancient glow. There is no privileged vantage, no cosmic center. The universe looks the same from everywhere, as though it's whispering that we are not outside of it, but inside its unfolding memory. Maps gave us the first precise numbers. The universe is 13.8 billion years old, composed of roughly 4.9% ordinary matter, 26.8% dark matter, and 68.3% dark energy. Planck refined those numbers further, sharpening the universe's self-portrait with extraordinary precision. Its detectors could sense differences in temperature of less than 10 millionths of a degree. Every variation became a data point, a note in the cosmic symphony. When the Planck mission released its full sky image of the CMB in 2013, humanity saw something few generations ever do: the literal face of the universe as a child. A marbled sphere of red and blue mottling, delicate and chaotic, yet perfectly balanced. It was humbling. Our entire cosmic history contained in a single shimmering pattern. But perhaps what is most moving isn't the science, but the poetry hidden within it. This map of radiation, this fingerprint of fire, is proof that the universe remembers. The light we detect today has traveled for nearly 14 billion years without interference. Each photon is a survivor, an unbroken thread connecting us to the first dawn. When you look at that map, you are seeing not just what was, but everything that could be. The seeds of galaxies, the whispers of gravity, the quiet promise of consciousness, all encoded in temperature ripples smaller than the width of a breath. Those ripples are the origin of contrast, of differentiation, of the possibility of anything existing at all. Without them, there would be no places to stand, no atoms to combine, no stars to ignite. They are the universe's first choices, the moment chaos hesitated and form was born. In that hesitation, everything emerged. It's strange to think that the uneven glow of this radiation would eventually sculpt beauty, that the slight excess of matter here, a slight deficiency there, would one day become the Milky Way, the Andromeda galaxy, the shimmer of Saturn's rings, the sparkle of oceans under sunlight. The faint ripples of ancient light became the geometry of wonder. The CMB also anchors our understanding of cosmic time. By comparing its measurements to the distribution of galaxies and the movement of distant supernovae, scientists can chart how the universe has evolved from that initial burst of radiation to the complex structure we see now. The expansion rate of the cosmos, the Hubble constant, finds its roots in those ripples. Even the tension between different measurements today hints that the universe may still hold secrets we've yet to unravel. Yet despite its complexity, the message of the CMB is deeply human. It tells us that everything began small, uneven, uncertain. That imperfection is not a flaw, but a necessity. Without the tiny ripples of imbalance, creation would never have found its form. The same principle echoes in our own lives. The recognition that meaning emerges not from uniformity, but from difference, from contrast, from imbalance finding harmony. When you look at the CMB, you are seeing the raw potential of everything that would ever be. A canvas painted not by hands, but by heat and gravity, by fluctuation and flow. The light itself became the artist, shaping the future with its uneven glow. The patterns it left behind were the first brushstrokes of cosmic architecture. Even now, that light continues to speak. It tells us how fast the universe expands, how matter bends space-time, how invisible forces shape the galaxies. And yet, beneath all that precision lies something even deeper. The realization that we, too, are part of that pattern. Our atoms, our bodies, our thoughts, all trace their lineage to those ancient ripples. We are made of ancient light, sculpted by its uneven glow. In this pattern lies every future the universe would ever know. From the simplest hydrogen clouds to the intricate web of galaxies, from the silence before stars to the roar of supernovae, every possibility was encoded in that flickering image. The CMB is not only a record of what has been, it is the promise of what will come. So when we look upon that map, those delicate swirls of red and blue, we are not merely studying the past. We are gazing into the moment when everything that could exist decided to begin. The universe was writing its first sentence, and we are still reading it, photon by photon, ripple by ripple. We are the continuation of that light, the living extension of its story. And in every direction, that story still glows, faint but eternal, the universe remembering itself through us. This isn't just light, it's time made visible. Every photon that brushes against our world tonight began its journey before there were worlds at all. It has traveled not through space, but through history itself, carrying the signature of expansion, the geometry of the cosmos, the slow unfolding of time into form. This ancient glow that fills every inch of the sky is not merely illumination, it is memory, stretched across eternity. When we study the cosmic microwave background, we are not just observing light. We are decoding the universe's autobiography. Each frequency, each ripple in that faint radiation, carries within it a record of how the cosmos expanded, how matter clumped, and how time itself learned to move forward. The CMB is not only the echo of the Big Bang, it is the scaffolding upon which reality is built. To understand the story it tells, we must first understand the language it speaks, a language of expansion. Since that first moment of release, 13.8 billion years ago, the fabric of space-time has been stretching like an inflating balloon. The galaxies are not moving through space. They are being carried apart by space itself. As the universe expands, it stretches everything within it, including light. The once blazing radiation of creation has cooled and softened, its wavelengths stretched by a factor of 1,000. What began as blinding brilliance has become a whisper in the microwave spectrum. This phenomenon is called redshift, the elongation of light as it moves through the expanding fabric of the universe. Every photon is like a violin string being pulled slowly across time, its tone dropping, its energy fading, but its story intact. The redshift of the CMB is a measurement not of distance, but of time itself. When we say the universe is 13.8 billion years old, we are not counting rotations of planets or orbits of stars. We are measuring the cooling of this light, the stretching of its wavelength from the white heat of the beginning to the chilled glow that surrounds us now. In a very real sense, the temperature of the CMB is the clock of creation. From that temperature, from its spectrum, scientists have deduced not only how old the universe is, but what it's made of and how it will end. The CMB confirms that the universe follows a model known as LCDM, lambda cold dark matter. Lambda represents dark energy, the mysterious force driving the acceleration of cosmic expansion. Cold dark matter represents the invisible scaffolding that holds galaxies together, unseen but undeniably real. Together, they account for 95% of everything that exists, leaving only a small fraction for the matter that makes up stars, planets, and life. The CMB tells us that space is astonishingly flat, not curved inward or outward, but balanced on a knife edge between open and closed. A flat universe implies infinite reach. It will never collapse back upon itself. Instead, it will continue to expand forever, though not at a constant rate. The discovery of dark energy revealed that expansion is accelerating, pulling galaxies apart faster and faster as time goes on. The faint glow of the CMB thus contains not only the memory of the beginning, but also the blueprint of the end. And yet, for all its precision, this radiation feels more like a ghost than a map. A haunting presence that never fades. The photons that make up the CMB have been traveling uninterrupted since the dawn of time, each one carrying the same energy it was born with, only stretched thinner by expansion. They are relics from a world that no longer exists, yet they remain with us, passing through every moment of our lives. In a way, they are the most faithful historians imaginable. Light remembers what matter forgets. Matter changes form, burns, collapses, erodes. Stars are born and die. Galaxies collide and merge. Atoms dissolve and reform. But the light from those first days remains almost unchanged. It moves forward through time, unblinking, impartial, enduring. Every photon of the CMB is a messenger from a past that still exists in the language of light, even if its matter has long since transformed. The universe, it seems, never truly forgets. It just translates its memory into wavelength. When we map the CMB, what we're really doing is eavesdropping on an ancient conversation between time and energy. Each ripple in temperature corresponds to a vibration in density, a pressure wave echoing through the plasma of the young cosmos. Those oscillations still hum faintly in the background of existence, their patterns frozen into light. They are known as baryon acoustic oscillations, the sound waves of creation. The universe at its birth literally rang. Imagine space itself as a vast lake struck by the first stone of existence. The ripples that spread outward have never stopped moving. Each crest and trough left its mark in the glow we see today, a pattern so subtle it took billions of years to interpret. The CMB, in this sense, is the echo chamber of the cosmos, still resonating with its first breath. This echo tells us something profound about geometry, not just of space, but of being. The light we see now was emitted from every direction at once, and yet all of it seems to come from the same surface, a perfect sphere centered on us. But this is true no matter where you are in the universe. Every observer, on every planet in every galaxy, stands at the center of their own cosmic sphere of ancient light. The farther we look back, the more the universe looks like a mirror, each point reflecting the same infinite pattern. There is no center because the center is everywhere. Philosophically, this symmetry is astonishing. It means that the universe has no privileged perspective, no single vantage from which reality is truer than another. Every observer sees the same beginning because every part of space was once connected. Every atom once bathed in the same fire. The CMB is the proof of unity, the evidence that all things share a single luminous ancestry. But it is also the proof of separation. As expansion continues, galaxies recede faster and faster, their light red-shifting beyond visibility. Eventually, entire regions of the cosmos will drift so far apart that even the oldest light will never reach between them again. The universe will fragment into islands of isolation, each one surrounded by its own horizon of forgotten light. In that future, the CMB will fade beyond detection, its wavelength stretched so long it will become silence itself. The echo of creation will persist, but only as absence. And yet, even that silence will mean something. It will mean the story was told. When scientists look at the faint mottling of the CMB, they see the fingerprints of space-time itself. The ripples are not just hot and cold spots. They are the imprint of quantum fluctuations from the first instant of existence, stretched to cosmic scales by inflation. They are the transition from probability to presence, from uncertainty to form. The universe began not with a smooth note, but with a trembling one, and that trembling became everything. Perhaps that is the deepest truth of the CMB. It is not perfection, but imperfection that endures. The light that fills the cosmos is not uniform. And because it is not, the universe exists. A perfect beginning would have led to nothing. It is the tiny differences, the delicate asymmetries, that gave rise to stars, to gravity, to thought. The universe remembers itself through its flaws, and those flaws are the origin of beauty. Think of the CMB as a memory written in radiation. If matter is the body of the cosmos, light is its mind, the record of experience that outlives every transformation. The photons that began their journey at the dawn of time still whisper their temperature, their direction, their tiny variations. The pattern they form is like a fingerprint, unique and unrepeatable. The universe will expand and cool. Stars will be born and die. But that fingerprint will never be erased, even now. Those ancient photons are streaming through you. Billions passing through your body every second, unnoticed, carrying the history of the universe in their invisible motion. You are literally bathed in the memory of creation. Every breath, every glance, every thought takes place within that silent glow. The cosmos does not merely surround you, it flows through you. You are made of the same asymmetry that shaped the galaxies, sculpted by the same echo that still hums between the stars. If you were to listen deeply enough, to tune your senses beyond the noise of the present, you might feel it, that endless resonance of origin. The CMB is not just a snapshot frozen in time, it is an ongoing symphony, each note stretched thinner as the universe ages, but never silenced. The frequency may drop, the energy may wane, but the music continues. One day, far into the future, long after the last stars have burned out and the galaxies have drifted beyond sight, this light will still exist, though faint beyond imagining. It will be the last remnant of the universe's memory, the faint afterglow of its own becoming, long after matter has forgotten its form. Light will remain to remember it. And when it finally fades, when the last photon is stretched beyond recognition and time itself grows cold, that too will be a kind of perfection. The echo resolving into silence, the memory completing its arc. The universe began in resonance and will end in rest. We are the witnesses caught between. We live in the brief, luminous interval when light still speaks, when the memory of creation still hums through the fabric of being. To look at the cosmic microwave background is to look into that echo and see ourselves reflected. Patterns of heat and time, consciousness and matter, bound together by the same primordial glow. This isn't just light. It's the sound of the universe remembering. A single cold patch in the sky might be a portal to another cosmos. It sounds like myth disguised as physics, the kind of story whispered by light itself when no one is listening. And yet, it's real. In the faint, ancient glow that surrounds us, the cosmic microwave background, there exists a region slightly dimmer, slightly cooler than the rest. Not by much, only a few 100,000ths of a degree, but in a universe that has spent nearly 14 billion years evening itself out, even the smallest imperfection feels like a confession. For decades, Scientists believed the CMB was smooth beyond belief, a uniform sea of radiation, disturbed only by those tiny ripples that would seed galaxies. But as telescopes sharpened their vision, as COBE gave way to WMAP and WMAP to Planck, new subtleties emerged. The glow wasn't entirely symmetrical. Some patches were warmer, others cooler, and one of them, the so-called cold spot, refused to blend in. The cold spot sits in the constellation Eridanus, a vast faint depression in the temperature map of the sky. Its size is staggering, hundreds of millions of light-years across if it corresponds to an actual structure in space. Its temperature is about 70 microkelvin lower than the average CMB. On paper, it shouldn't exist. Statistical models predict fluctuations, yes, but none so large, so coherent, so hauntingly distinct. It was as if someone had pressed a finger against the universe's first photograph, leaving a dent that time itself could not smooth away. So what is it? Some physicists think it might be nothing extraordinary at all. A statistical accident, a random low point in the cosmic temperature field, one improbable pixel in a vast tapestry. Others propose that it might correspond to a supervoid, a vast region of space unusually empty of matter. Light passing through such a void would lose a bit of energy due to the integrated Sachs-Wolf effect, stretched slightly by the expansion of space as it climbed out of the shallower gravitational potential. This could, in principle, produce a faint coldness in the background glow. But there is another, more unsettling possibility, that the cold spot is a scar left by something beyond our universe. Some cosmologists suggest it might be evidence of a collision, not between galaxies, but between entire universes. In the early inflationary epoch, when space-time expanded faster than light, countless bubble universes could have formed within a grand multiverse, each with its own physical laws, constants, and histories. If one of those bubbles brushed against ours before inflation ended, it could have left behind a mark, a bruise in the cosmic microwave background, a circular anomaly imprinted into the very fabric of the sky. The cold spot, then, could be the boundary between realities, a place where two cosmic embryos once touched, leaving behind a faint whisper of that impossible encounter. It's a hypothesis so vast that even the language of science trembles under it. To imagine that our universe is only one of many is to imagine an infinite sea of creation, universes sprouting like foam on a cosmic tide, each carrying its own version of physics, its own arrow of time. If that's true, the CMB might not just be a memory of our beginning, but a record of neighboring beginnings as well. The echoes of other worlds bleeding faintly into our own. But even if the cold spot isn't a portal or a bruise, it still tells us something profound. The universe remembers more than we can decode. The CMB is like an ancient manuscript, most of it legible, but certain passages smudged, rewritten, or crossed out. The noise, the asymmetries, the statistical anomalies, these are not flaws, but footnotes, hints of something deeper beneath the surface. To read those faint irregularities, we must journey back to the very first instant. Before recombination, before the fire cooled, before even the inflationary expansion had finished sculpting space-time. In that fleeting moment, less than a trillionth of a second after the Big Bang, the entire universe existed as a quantum field. Random fluctuations in that field, tiny quantum jitters in energy density, were stretched by inflation to macroscopic scales. Those ripples became the seeds of structure, the imprints of quantum uncertainty etched across the cosmos. Every galaxy, every star, every atom that would ever form traces its ancestry back to those initial fluctuations. They are the fingerprints of quantum mechanics on the face of eternity. Inflation magnified them a billionfold, freezing them into the geometry of space-time. And when light finally escaped, when the CMB was born, those frozen ripples became visible as the faint mottling we now see in the microwave sky. In this sense, the CMB isn't just the afterglow of creation, it's the photograph of a quantum dream. It shows us what happens when uncertainty becomes reality, when probability becomes history. Each patch of brightness, each pocket of cold, corresponds to an ancient quantum fluctuation that decided, by chance, to become something rather than nothing. The galaxies we see today are the echoes of that decision. Inflation itself remains one of the most extraordinary ideas in physics, a theory so powerful it explains nearly everything about the early universe, yet so mysterious we can't fully prove it. It proposes that a tiny region of space-time, smaller than an atom, underwent an exponential expansion driven by a vacuum energy field. In less than 10 to 32 seconds, that region inflated into a cosmos large enough to encompass everything we see. This process smoothed out irregularities, flattened space, and set the initial conditions for the Big Bang as we understand it. But it also created the potential for countless other regions, other universes, to inflate elsewhere, each forever sealed off by horizons of space and time. If inflation happened, its fingerprints should be visible in the CMB. Scientists have searched for them, for specific patterns in the polarization of its light, known as B modes. These subtle twists could reveal the presence of primordial gravitational waves, ripples in space-time created by inflation itself. Detecting them would be like hearing the faint echo of the universe's first heartbeat. In 2014, a telescope at the South Pole called BICEP-2 announced just that: the possible detection of those ancient gravitational imprints. For a brief, exhilarating moment, it seemed as though we had found direct evidence of inflation's fingerprints written in light. But further analysis showed that interstellar dust, not primordial gravity, had mimicked the signal. The echo remained elusive. Yet even in disappointment, the search deepened our awe. To detect a pattern a billionth the strength of daylight, buried in radiation older than time, what greater act of listening could there be? The quest continues. Future missions like CMB-S4 and Light Bird aim to measure the polarization of the CMB with even greater sensitivity, peeling back layer after layer of that faint glow. Each new measurement refines the map of the cosmos, sharpening the line between the known and the unknowable. The more precisely we see, the more mysterious the universe becomes, because beneath the clarity of the CMB lies something paradoxical. It both reveals and conceals. It shows us how the universe began, yet hints at what may never be known, what existed before the beginning or beyond the boundaries of our cosmic horizon. It is both a mirror and a veil. The farther we look, the more we glimpse not an edge, but an invitation, the suggestion that the universe's light folds inward, that it reflects itself in endless recursion, like thought observing thought. If the cold spot is just one ripple in that self-reflecting ocean, what might the deeper patterns mean? Are we glimpsing the imprints of other realities, or simply the complexity of our own? Perhaps both. The multiverse, if it exists, isn't a collection of separate worlds floating in space. It's a consequence of quantum mechanics itself. Every possibility written into the same cosmic equation. Inflation could have fractured the wave function of reality into countless outcomes, each one expanding into its own version of existence. And if that's true, the CMB might be the faint interference pattern where those realities overlap. The first light not of our universe alone, but of reality's entire spectrum. There's an almost spiritual symmetry in that idea, that the oldest light we can see might not be ours exclusively, that our universe's memory could contain echoes of others, universes that bloomed and vanished, or perhaps still expand beyond our reach. It makes the cosmos feel not solitary, but symphonic, a vast chorus of beginnings, each singing its own version of the same eternal note. And yet, for all the grandeur of such speculation, the CMB remains humbling in its precision. Every measurement confirms that, at its core, the universe follows rules of astonishing consistency. The temperature of the radiation is the same to within 1 part in 100,000. Its spectrum follows the perfect curve of a blackbody, unbroken and flawless. If there are secrets hidden within it, they exist not in broad strokes, but in the subtleties, in the faint, whispered deviations that speak of something more. Perhaps that is the true beauty of the CMB. It is a message written in paradox. The universe is both simple and unfathomably complex. It is governed by laws that fit into equations, yet pregnant with meanings that defy all language. The same light that reveals structure conceals mystery. The same glow that explains our origin hints at countless others. The CMB is the ultimate paradox, a surface of answers stretched across a depth of silence. Even now, as we map its faint irregularities, we sense there is more beneath the glow. Each new refinement of data removes noise, sharpens resolution, clarifies structure. And yet, behind every correction, something unexpected lingers. There are asymmetries where none should be, alignments between hot and cold spots that defy randomness, patterns that seem to whisper of intention, though none exists. It's as if the universe is composed of secrets that prefer to stay half-revealed. Light may be the most honest thing in existence, but it never tells the whole truth at once. When we stare into the CMB, we are not just seeing the universe as it was. We are seeing a reflection of what it could still be. Beneath its glow lie layers of quantum potential, of fluctuations too subtle to detect, yet too real to deny. The CMB is not a static photograph frozen in time, but an evolving dialogue between the known and the unknown, between physics and philosophy, between measurement and meaning. If this pattern hides another reality, it means the first light wasn't the beginning, just the first echo. Inflation may have birthed not one universe, but an infinite ocean of them, each expanding into its own vastness, each carrying a version of this same glow. The light we see could be the shimmer of many beginnings overlapping, the interference pattern of eternity itself. And maybe, in some faraway cosmos beyond our own, another civilization is looking up at its own version of the sky, finding its own cold spot, asking the same impossible question. What if the universe we know is just one thought in a mind too vast to comprehend? And the CMB is the afterimage of that thought lingering across time. The farther we look, the more we realize the glow doesn't end. It only deepens. Long after the last star dies, this light will still wander the void. When the galaxies have dimmed into ghosts, when the fires of creation have long been extinguished, the oldest light will continue to drift. Faint, tireless, eternal. The cosmic microwave background, that soft whisper from the beginning, will outlast everything that burns. Even in the silence after time's final breath, photons will still move, carrying with them the last memory of what it meant for the universe to shine. We often think of light as fragile, as something that vanishes when a flame goes out or a star collapses. But photons are remarkably enduring. Once released, they travel endlessly unless absorbed or scattered. The CMB's photons have been journeying through the cosmos for nearly 14 billion years, slipping through galaxies, brushing against atoms, weaving through voids wider than imagination. Every one of them is a survivor of eternity's longest night. Their fate is tied to the fate of everything. As the universe expands, the wavelengths of those photons stretch, their energy fading with the cosmic redshift. What was once brilliant becomes dim. What was once heat becomes cold. Yet they never stop moving. They are the most persistent travelers in existence, forever chasing horizons that recede faster than they can reach. Light never truly dies. It just grows quieter. In 100 trillion years, when the last stars exhaust their hydrogen and go dark, when galaxies crumble into drifting embers, this ancient radiation will still be there, stretched thinner but unbroken. The CMB will fade from microwaves into radio waves, then into wavelengths longer than planets, longer than galaxies themselves. Eventually, it will slip beyond detection, merging with the faint hum of the universe's expansion. But it will still exist, the last echo of the first moment. This is the poetry of physics. Energy never disappears. It only changes form. The first light still glows, transformed but unforgotten. It is a fossil not of matter, but of time itself. A photon that began its journey when the universe was a fog of hydrogen might still be racing through the emptiness at this moment, brushing the edge of some forgotten galaxy, unseen but not gone. Every photon is a memory. It remembers where it came from, not in thought, but in wavelength, in frequency, in motion. Its redshift is a record of everything that has happened since it was born, the measure of how much the universe has grown. Light carries history the way stone carries fossils, or consciousness carries dreams. Each photon is a story the cosmos refuses to stop telling. The CMB, in this sense, is the universe's autobiography written in motion. It has no language, no ink, no voice, and yet it speaks. It tells us how space stretched, how time cooled, how gravity sculpted everything we see. It tells us that existence was not a single act, but a continuous unfolding, that the first light did not end. It became everything. As time moves forward, the great structures of the universe will continue to drift apart. Galaxies already recede from one another faster than the speed of light, carried away by the stretching of space-time. One day, even the closest clusters will slip beyond the cosmic horizon. The night sky will empty, one star at a time, until only the faint background glow remains. To any observers that may exist in that distant future, the universe will appear cold, dark, and silent. And yet, somewhere in that silence, these same photons will still be gliding through the dark, the last remnants of the dawn. It's humbling to realize that light, not matter, not form, is the one constant thread between the beginning and the end. Matter decays, stars die, even black holes evaporate through Hawking radiation, but light endures. It may fade into invisibility, but it never ceases to move. It carries with it the memory of every atom, every collision, every heartbeat of creation. Perhaps that's why we find light so deeply symbolic, why every culture has treated it as the essence of being. In the universe, light isn't merely illumination, it is persistence. It is the bridge between creation and memory. It is the medium through which the cosmos keeps track of itself. When we gaze up at the night sky and catch the faint shimmer of starlight, we are participating in that same act of remembrance, receiving messages sent millions or billions of years ago, proof that nothing luminous ever truly disappears, and perhaps, by extension, consciousness is the same. Our thoughts, our awareness, our ability to look up and wonder, these are the universe's newer forms of light. Within the neurons of the mind, electrical signals flash and fade, yet the act of perception connects directly to the act of illumination. We are organisms built from the cool debris of stars, yet our brains produce radiance of their own, a light that sees, reflects, and remembers. It's tempting to think that the persistence of photons and the persistence of awareness are two faces of the same cosmic impulse, the drive to endure through change. In a way, the CMB is not only the memory of the universe's birth, but a metaphor for the continuity of consciousness itself. Both are forms of light, one external, one internal. Both exist because of difference, fluctuation, imbalance. Both stretch and evolve, fading in intensity but not in meaning, and both may continue far longer than their original spark should allow. Imagine, then, the very end, a time when entropy reigns supreme, when even black holes have dissolved into radiation. The universe will be vast and nearly empty, filled only with low-energy photons drifting endlessly through a cold sea of nothingness. It will be a place without structure, without form, without time as we know it. Yet even then, the CMB, now stretched beyond all measure, will still glide through that frozen eternity. The first breath of creation will still be exhaling. In that distant silence, the universe will no longer make stars, no longer dream of life, no longer witness its own beauty, but the light will remain as testament, a faint glow testifying that it once was alive, once was curious, once was radiant. The cosmos will have grown old, but its memory will still hum softly beneath the threshold of perception. And perhaps that's all any of us can hope for, that something of us endures, some faint signal, some wavelength of thought or kindness or discovery that continues on, carried through time long after our own stars go out. If the universe remembers through light, then so do we, through the stories we tell, the questions we ask, the awe we leave behind, every photograph, every act of wonder, every moment of recognition. These are our echoes of the same ancient impulse that sent photons across eternity, the desire to see, to illuminate, to remember. The universe has been shining since before there were eyes to see it, and perhaps it shines still through us. Maybe the oldest light is not only the CMB, but the spark of awareness it inspired. the moment a mind looked up and realized the sky was more than darkness. That act of recognition is itself a form of light, a continuation of the same flame that began 13.8 billion years ago. Long after the last star dies, the light will still wander. It will no longer be visible, no longer warm, but it will still move, still carry the memory of being. And perhaps, somewhere in that endless drift, another consciousness will awaken and look out into the dim remains of creation, catching the faintest echo of our own beginning. Then, once again, the universe will remember itself, because light never truly fades. It only changes form, from brilliance to whisper, from energy to thought, from cosmic dawn to human wonder. And even when all else is gone, it will remain, the silent witness to everything that ever was, and everything that still could be. Perhaps the oldest light didn't travel across space. It traveled toward understanding. For nearly 14 billion years, photons have wandered the dark, carrying the memory of the beginning. They crossed the newborn fog, slipped past galaxies, and outlived stars. They survived the deaths of suns, the collisions of worlds, the rise and fall of everything material. And now, after eons of blind journeying, they arrive here. Not just upon Earth, but upon awareness, upon us. When we lift our eyes to the night sky, we are not merely observers. We are participants in the same story those photons have been telling since the dawn. The light we detect, the faint whisper of the cosmic microwave background, is not just what we see. It is what sees through us. We are the final surface upon which that ancient radiance lands, the moment when the universe's first memory becomes reflection. Long before there were eyes, there was sight waiting to happen. Long before there were minds, there was meaning waiting to awaken. The light that filled the cosmos at its birth has spent eternity searching for something capable of remembering it. And in consciousness, it found its mirror. Every act of looking is a reunion. Every thought of wonder a continuation of that first illumination. We often speak of ourselves as small, as insignificant specks in a vast and indifferent void. But when you think of what truly happens when you gaze into the darkness, that story changes. The light that touches your eyes began its journey at the universe's beginning. It has traveled longer than time as we know it, carrying with it the imprint of creation. And when it enters your vision, it does not vanish. It becomes part of thought, part of comprehension. The cosmos, in that instant, recognizes itself. We are made of the same atoms born in the first fires, cooled from the same plasma that once held light captive. The hydrogen in our blood, the carbon in our cells, the calcium in our bones, all forged from the ashes of stars that were themselves kindled by the forces imprinted in the CMB. We are literally woven from the universe's earliest energy, crystallized into matter that could look back and ask what it is. Perhaps the truest purpose of that first light was never to illuminate space, but to illuminate awareness. It did not merely scatter outward. It evolved inward, from energy to matter, from matter to life, from life to curiosity. The same photons that once painted the universe's first image now spark the neurons that imagine its meaning. The same glow that once filled the cosmos now flickers behind human thought. We are the universe, finally opening its eyes, What the telescopes see in the CMB, that faint, all-surrounding radiation, is not just a relic. It is a living memory. It hums in the background of every moment, vibrating through every atom, every breath. It is the first breath of everything still exhaling. When we study it, we are not looking outward. We are looking backward and inward all at once, peering into the roots of existence and finding our own reflection there. Every scientific measurement, every chart of temperature variations, every frequency captured from the sky is, at its heart, an act of remembrance. The instruments are our extensions, mechanical eyes for an organism made of light. They gather the echoes so that we can translate them into understanding, into poetry, into awe. Maybe the greatest paradox of all is that the same light we measure is the light that allows us to measure at all. Without it, there would be no eyes, no stars, no thought, no meaning. We are both the receivers and the continuation of that radiance, both the question and the answer. The universe began by shining, and in us it shines again. If the CMB is the memory of the cosmos, then consciousness is its dream, the way the universe contemplates what it became. We do not stand apart from it. We are its latest expression. The photons that left the first dawn have finally found something capable of wondering why they began their journey at all. Perhaps that is the final purpose of light, to know itself. To begin as fire and end as understanding. To travel not only through space, but through meaning. Every look into the darkness, every act of curiosity, is a photon completing its circle, from creation to comprehension. So when you next gaze at the night sky and feel small beneath its enormity, remember this. The light entering your eyes is ancient beyond measure, but it has finally come home. You are not looking at the universe. You are the universe, looking at itself. The first light remembering its own beginning through you. And that means the journey never truly ended. The photons will keep traveling, the cosmos will keep expanding, and thought will keep awakening wherever light finds a way to see. The act of illumination continues, not as an explosion, but as a realization. The dawn of the universe was not a single moment long ago. It is still happening, right now, wherever awareness meets wonder. Maybe the oldest light was never about brightness at all. Maybe it was about becoming. About the universe learning to see what it was, about memory turning into meaning, and so it lingers, in the sky, in us, in every question that burns against the dark. We are the light remembering itself.